Hey there, how are you? I am Pavani. In this video, we're gonna learn about HDFS. First, we're gonna see some basic details about it and its architecture, and then we will see its commands, and we're also gonna execute them in the cluster. So by the end of this video, you're gonna learn everything that you need to know about HDFS. Before we start, if you're new to the channel, please do subscribe and hit the bell icon so that you don't miss any updates. With that being said, let's get into the video. I'm gonna see you on the other side of the intro. So we're going to see the basic details of HDFS, then its architecture, and then the commands of it. HDFS, which stands for Hadoop Distributed File System, is a storage component of Hadoop. It is the underlying storage for all Hadoop services like Spark, Hive, HBase, etc. If you know about Hadoop, you will understand what I just told. Even if you don't know, then also it's fine. We don't have any prerequisites for this video. It's only limited to HDFS. So just think of it as a storage service. Coming to background, HDFS was developed using Java. You don't need to learn Java to use this, by the way. It was developed in 2004 as part of Nudge project and originally called as Nudge Distributed File System, NDFS, and was merged to Hadoop in 2006. Coming to the features of it, it has the ability to process large amounts of data, that is even terabytes and petabytes. As name suggests, it stores the data in distributed manner. For example, if we have 1 GB of data, instead of storing it into one machine, we split it into 5 parts of 200 MB each and store it in 5 machines. Each part of data is called a block in HDFS. So we split this 1 GB data into 5 blocks B1, B2, B3, B4, B5 of 200 MB each and store it in 5 machines. By doing this, we get the opportunity for parallel processing and faster access to the data. And it is fault tolerant. How? Let's see. After we split 1 GB data into 5 200 MB blocks, we not only store each part in different machine, but we actually replicate these blocks more than one time throughout these machines. So B1 will be replicated into machine 2 and machine 3. Like that, B2 will be replicated into machine 1 and 3. Likewise, B3 will be replicated into machine 1 and 2, B4 into machine 5 and 6, and B5 into machine 4 and 6. Now let's say machine 1 failed. What do we have in machine 1, B1, B2, B3? We don't lose the data because we have replicated them in machine 2 and 3. We can access it from there. So by like this, we can achieve fault tolerance. That's about features. Let's move to architecture. In HDFS architecture, we have data nodes and name node. Data node is where our actual data will be stored physically, and name node, which is also called as master node, maintains the metadata about which data nodes store particular blocks. Let's see the example. Now we know what we call these machines that store the actual physical data. I'm going to change their names from machines to data nodes. Like that. So we have one file with 1 GB data size. It was split into 5 blocks of 200 MB each and stored and replicated into these 6 data nodes. The name node is the one which stores the metadata of these data nodes and blocks. That would be like file info, block info, and in which data node that block of that file was stored. So all these blocks here belong to only one file, which is file 1, let's say. So file 1's block 1 is available in data node 1, data node 2, and data node 3. That information we have here. Likewise, file 1's block 2 is available in data node 1, data node 2, and data node 3. We have it here, and so on up to block 5. We have the data nodes information available in name node. So whatever data we need, first we check in name node like where it is available, and accordingly we can directly go to that data node to access that particular data. The default block size in HDFS is 128 MB. You can change it if needed. Now let's get into the commands. Most of the HDFS commands are similar to Linux commands, except they will be prefixed with either Hadoop FS or HDFS DFS followed by respected command. So if you know Linux already, this should be easy for you, but even though you don't know Linux, still it's easy, we will learn now. So In Linux, by doing ls, you can see the list of files that are available in your current directory. Here I have some 3 files. Prefix it with HDFS DFS and give ls. You can see the list of files in HDFS. Here I have 3 folders in my root directory: trash, hijaz, and some demo directory. Now give HDFS DFS ls and then specify this demo folder. You can see the list of files in that particular folder. Here I have one file named sample1.csv. Here you can see the file name along with its path of a location where it is actually stored. But what do these remaining columns mean? Let's see. So the first letter in the first column tells us whether the item is directory or a file. Here I have all 3 directories, so the first letter is D for all of them. And then here this is a file, so the first letter is hyphen. And the remaining string tells us the permissions of the particular directory or file. And then the next column is for replication factor. This is not applicable for directories, so here you can see hyphen, but here you can see 1 as the replication factor for this particular sample1.csv file. So I am executing these commands in my local HDFS cluster. That is the reason it is 1. But if you see it in your company, or if you see the replication factor of some file in an actual Hadoop cluster, you can see the replication factor as 3 or more. Replication factor means how many times the file is stored, how many times it is replicated. And then the next column is username of the owner of the file or directory. In this case it is root. And then you can see the group name to which this directory or file belong to. Here defaultly it is HDFS. And then for file you can see the size of the file in bytes. Here this file is of size 1098 bytes, and then followed by, you can see the last modified timestamp of that particular file or directory. So that is what these fields represent. Next, by using mkdir command, you can create a new directory. Give the name of the directory after HDFS DFS mkdir. Here I gave demo2. A new directory will be created with that name. Now if I give ls, we can see the new directory demo2 in the list. I had cleared my screen here. I give ls. I have 3 files here, configuration file and 2 CSV files. Let's give ls for our newly created directory demo2. I get empty list because we didn't copy any files here yet. Now by using copy from local command, we can copy files from our local system to HDFS. Give the file name you wanted to copy to the HDFS. I want to copy this sample1.csv and give the path in HDFS to where this file has to be copied. I want this file into this demo folder. Press enter. Now if I give ls to demo2 again, I get the result. You can see it was copied now. You can do the same by using get command. I wanted to copy sample2 this time to the same folder demo2. I get error because I was wrong. My bad, this is not get but put. So I will replace this with put. And I want to copy sample2 file from my local system to demo2 folder of my HDFS. This time it will execute correctly. If I give ls on demo2 again, you can see both the files. So if you want to copy the files from your local system to HDFS, you can do that by using either copy from local or put command. So I just gave ls again. I have 3 files here. I want to delete sample1. So I will use rm command followed by file name. It is asking for confirmation. I will say yes, and it was deleted. If I give ls again, you can see sample1 is not here. Now I want to copy this sample1.csv file from HDFS to my local system. This time we can use get along with the path of the file I wanted to copy from HDFS and the local system path where I want it to be copied. I gave root path here. Now the file will be copied from HDFS to local system. I will give ls. We don't have sample1 here because I gave root as my local system path here. So I will give ls to root. Then we can see sample1.csv is here, which was copied from HDFS. So if you want to copy files from HDFS to local system, you can use get command. I will clear the screen, and by using HDFS DFS cat command, you can see the contents of any file. Give the path of the file here and press enter, and we get the contents that are in sample1.csv. Now I just want to see the list of files in demo folder once. We have sample1.csv. By using cp command, we can copy the files from one location to another location within HDFS. Give the path of the file which you wanted to copy and followed by the path to where you want to copy it. I want to copy sample2.csv from demo2 folder to demo folder. This will be copied. Now if I give ls demo again, I have two files since we copied this one just now. Instead of copying, if you just want to move the file, you can use mv command. Give the source from where you want to move and destination to where you want to paste. Press enter. This is we already have a file named sample2 in demo2. So let's delete it first. To delete any file in HDFS, you can use rmr command. Give the path of the file which you wanted to delete. We wanted to delete sample2.csv in demo2 folder. So this is it was deleted and moved it to trash. Now if I give this mv command again to move sample2.csv from demo folder to demo2 folder, this doesn't throw the error. This will move the file. Now if I give ls demo, we only get sample1.csv as a result because we moved sample2.csv to demo2 folder. So by using cp command, you can copy the files between HDFS directories. By using mv command, you can move the files. I cleared the screen here, so I will just give ls trash. Here we got some directories. Remember we moved some files to trash before, so if we wanna empty the trash, we can just do expunge command and it will delete all the directories or files that are in your trash bin. So that's about HDFS and its commands. Congratulations, you made it to the end of the video. Thanks for watching.